It is common for problems in circuit theory books to include schematics that have several elements with symbolic values, but that also provide you an equal number of numerical answers. And the idea behind these problems is often to find, through the use of these known answers, the values of the elements that were given as symbolic. In Symbulator, we have a tool for solving this type of problems. This is an example of this type of problems. As you can see, we have here several elements whose values are symbolic. For example, R1, we don't know the value in ohms of this element. R2 is also unknown. R3 is also unknown. RL1 and RL2 are also given as symbolic. So we have 5 elements with unknown values. To compensate for this, we are given a series of numerical answers. We're given a 20 milliampere current, a 10 milliampere current, a 60 volt voltage drop, a 20 volt drop, a 50 milliampere current, and a minus 12 voltage in a node. So we're given 6 numerical answers. Actually, all we need is 5. We need an equal number of numerical answers than unknown values we have. So 5 is enough. We're not going to use the minus 12. Let's see now how we can solve this problem using the expert mode. The question is to find the values for the resistors and to figure out if 2 watt resistors can be used. This is the circuit description. Nothing new here except the fact that we're using RR1, RR2, and RR3 for the symbolic values of these 3 resistors. We will see in a moment why. So we type this circuit description in the text editor and then we copy it. We're going to put it into a variable. As you know, I like to use the variable CIR. And then we're going to invoke the expert tool, which is EX, and ask the calculator to run it for that circuit. We specify DC as the type of analysis, and then we will get a dialog asking for some information, such as equations to be added, unknowns to be added, and conditions to be added. These are all optional. Let's see what we mean by this. The expert mode requires us to provide an equal number of equations and variables if we want to obtain numerical answers. So here we will write 5 equations and provide 5 variables. You can see here the 5 equations. Notice the current has the current in the source has a negative sign because the direction in which it's flowing. Notice also that the equations expressing these known values are separated using the AND term. This is required. And then notice that the variables are separated using commas. This is required because of the syntax of the solve command of the calculator. So now let's type this into the dialog. So in this dialog window, we will type the equations separated by ANDs, and we will type the unknowns separated by commas. We know that we have a current in the source that is minus 0.05 because of the direction in which it's flowing, and we also have a current through resistor resistor RL1 that is 0.2, and we have a current through resistor RL2 which is 0.01. We have a voltage drop in resistor RL1 which is 60 volts. We have a voltage drop in resistor RL2 which is 20 volts, Those are our 5 equations. And then now the unknowns are RR1, RR2, RR3, RL1, and RL2. So we go on, there's no conditions in this example, and we specify that we want to simulate and keep the equations and unknowns. You can also just specify that you want to simulate. Keep means that you want to keep the expression for the equations and the unknowns stored in the memory as a string. Now that we have solved the circuit, we can proceed and ask for the values of RR1, RR2, RR3. You can see that all these values were already stored in the memory. That's what the expert mode does. And we can also check for answers within the circuit for things like power or voltage drop or current. Remember that the name of the resistor is R1, even though its value is RR1. The power would be PR1, which is the name of the resistor. PR2, PR3, you can see all of these are less than 2 watts. Let's see the power in the load resistors, but I think the problem was referring to the circuit resistors. So but all the powers are less than 2 watts, so yes, we can use 2 watt resistors. And these are the right answers. So now that you have seen that the expert mode gave us the values for RR1, RR2, and RR3 stored in those variables, I can explain to you why I used those instead of using R1, R2, and R3, which is my usual custom. The calculator has R1 as a reserved variable such that you can use it as a symbolic expression, but you cannot store values in it. You cannot store anything in R1 through R99. Therefore, if you want to use it symbolically, you can refer to R1. But if you want to store something in it, like is the case in the expert mode, then the calculator is going to give you an error. That's the explanation.